Okay, so let's see, nums. Equals. I'm just going to do that right there. So I've set aside 10 spaces. Let me double check something because I don't have any kind of visual on whether the sound is loud enough or not. Test 1 2 3. No, where are you? 1 1 1. Turn this up a little bit. Test, test, test. Okay, that's probably better. All right, so I've got this over here, and I can do all sorts of stuff with it. I can say, like we talked about yesterday, for these really come in handy for just using loops with, but I can say int y, yeah, let's do this, nums. I can pick a specific spot. So if I say nums 5 equals 7, well, what's that doing? Which slot is this? Thank you, the 6th one, because we always start at 0. So it's the 6th one. So in that 6th slot, I'm putting the number 7. I could ask the user, I mean, there's all sorts of ways we can do this. And I can say cn, and I can say nums whatever. If I say nums 0, remember, this is just where I'm going to store it. I can say nums 9. I'm not trashing anything out there. Gets the value 20. I can say nums 8 gets curses. Nums 8 gets the value 15. I can say nums 2 equals nums 9 plus nums 8. See, so anything I can do with just a regular old int, I can do with array elements. Each one of these is called an element. So here's an element in at index 5. Here's an element at index 9, which is the 10th slot. Here's, and so on. So I can take these, and they're just regular old ints. The beauty of it is I don't have to give them individual names. That's the real power of this. So if I wanted to print out this array, I could say for int x equals 0, x less than 10, x plus plus. It'll only go to 9. That's why I'm saying less than 10. See, if I put less than or equal to 10, I'm not going to like the results. We'll try that in just a second. And I'll say cout nums x. So with 2 lines of code here, whoa, where'd that come from? 2 lines of code, I can print out the entire array. You all think with me. What if I had 1,000 things in the array? How many lines of code would it take to print out? 2. All I'd have to do is change this 10 to 1,000. Okay, let's see if this even works. Come here, screen. Enter value. So that's that first one up there. So I'll put 100. Whoa, what happened? Yeah, see, there's just junk values in here. So that 100, this first 100 came from right here. Notice nums 5 has a 7 in it. Here's that nums 5. So this 35 came from adding these two together. You never know what they're going to be. It depends. See, this computer just started up. It literally depends, because what if another program had been running where mine is loaded into RAM now? It's set to whatever that other program set the RAM to. So if I had just written a letter in Microsoft Word and then saved the letter, exited Word, well, Windows doesn't go in there and clear out all that memory. That'd be pretty inefficient. It just leaves it. So there's actually spyware kind of things that'll go through and find stuff that's still in RAM, because you could get my whole letter if you knew where to look in RAM. And so what if this program loads in right on top of that where it was? Then all of those switches are going to be set where they were for that letter. And, so you don't know. Here, because it just started up, I'm thinking they're all probably going to be about the same. That's a good question. You just don't know. That's why we call it junk. They have junk values. Okay, on this so far, anything not making sense based on what you read? All right, I can change that then. Where are you, mouse? There it is. I'm going to leave that. I'm going to say for int x equals 0, x less than 10, x plus plus. I can say nums x. Notice x is changing from 0 to 1 to 2 to 3 to 4 to 5, 6, all the way up to 9. I can say nums x, that slot number, let's make it x times 100. So look what I'm doing. I'm saying whatever x is, multiply it times 100, store it into slot x. And so then we're going to print it out. And here's what we get. All right. So you can manipulate arrays in a whole bunch of different ways. And part of what we're going to be learning about in Chapter 7 here is how to do just that. And yes, we're going to get to vectors toward the end of this. And I'm thinking about the project. It's going to have arrays in it. So that's a good thing. You're going to be able to write. You're going to be able to do a lot of stuff with not much code. I'm going to pause. So when I run this, we already looked at it. It gives me this right here. So we're picking back up. We close that. Here's something else the book mentioned. I'm just going to comment this out for a second. What if I wanted to know how big this is, how big that array is? I could say cout size of nums. Watch what happens. Look what it tells us. 40. We just now started back, Satchel. We thought you'd escaped or something. Okay, if I say size of nums, it's saying 40. What's wrong? Hannah? Thank you. Yeah, 40 bytes. So watch out for that size of thing. It doesn't tell you how many slots. It tells you how many bytes. Now, if I wanted how many bytes, what would I do? couple of ways I could do it. One is, say, divide by the size of, and then I could just pick an element because they're all the same, right? They're all ints. So I could just say nums 0. Doesn't matter. Now what am I saying? Yeah, and this, yeah, and on most machines an int is 4 bytes, so I should get 10 now. Yeah. So if the moral of that story is, if you want the size in this number of slots, you got to say size of the whole array and then divide by the size of one of the elements in there. So if we made this doubles, double nums, is that code still going to work? Why? Okay, now is that going to work? Golly. Here we go. Let's try it. 10. And I think a double takes up, what, 8? Something like that. But it's machine specific. So on these IBM compatible machines, it'll be 8. But on an IBM mainframe, it might be a lot more or a lot less. You just don't know. So doing this kind of code, you can check on whatever machine you're on. What if, and here's what I really prefer that y'all do. Come up here, make a global constant. I hope y'all got my email. Please don't use global variables. It's just not good. But I can declare a constant up here and say, call it array size or something. And I've noticed when y'all declare constants, some of you are doing that really well, but you're forgetting that the custom is to make it all caps. So another programmer, when they see constant, they're expecting it to be all caps. So if you can remember that, that would be fantastic. So what if I said this, 10? And then down here, I can put array size. Now if you read, you know this is going to work, because this has to be a constant value. It either has to be a literal or some constant to go in here. Well, that should still work then. So I'll compile it and drag this little guy over here, and I'm good. I'm good. All right, so we've gotten size of in there. Please get used to doing this, because when you do a loop, for instance, if I wanted to print out all of these things, I'm going to put it back to ints. Maybe lowercase int. Take this out and put these back. Instead of having a magic number like this 10, that we've talked about this before, why do you want to use constants? Well, because as your program's going, you might have that same number in 50 different places. You don't want to have to go back. What if I change my array size to 30 or something? I don't want to have to go back and find all those 10s. So here I can put array size. Here I can put array size. And everything should still work just fine. Oh, I'll say that. Oh, thank you. Out of sight, out of mind, I guess. There we go. Does that work fine? So I know the book mentioned this, but it really is a good idea. So please start doing that. Declare a constant for that. What am I leaving out? Because I want you to have some programming time today. Input and output, we just did. The slot numbers start at 0. Okay, let's do that. I'm going to take this code out where I'm sticking values in there. Suppose I know ahead of time what some of my values are going to be. Well, I can use curly braces here, and I can say, all right, I want that first value to be 23. I want the next value to be 67. I want the third value to be 100. But I haven't put 10 numbers in there. I've put 3, which means slot 0 will get the 23, slot 1 will get the 67, and slot 2 will get the 100. So when I run this and print it out, notice the first 3 are going to have good values, and the others are probably going to have junk. Okay? We good? Because when you start initializing an array, the compiler goes ahead and says, well, since you're starting that, I'm going to stick zeros in there for you on the others. Now, if I declared a global array up here, hint, hint, don't, it'll make all of them 0. What if I did this? What if I took this out? Now what's going to happen? Yeah, see, how many values do I have in my array now? How many slots? 3. Because this is that implicit array sizing, and the only way you can do it, is if you have initialization out here. And the compiler, this is kind of a lazy way of doing it. The compiler says, okay, you got those 3, you didn't tell me how big you want it, it's 3. What's going to happen when I print them out? Because I'm going to 10 down here. Is it going to crash? Man, let's see. This is exciting. Uh-oh. We're back to junk. It put our 23, our 67, our 100 in there. How many did I tell it to print out? 10. Now, did you read in the book, it says, was it in the reading from last night that says there's no bounds checking? Did right here, right here, it went to 10. Where to get those other 7 numbers? But where did it get those values? What if I had been storing stuff in there? Let me show you. What if I said down here, I've got my array here, and down here I'm going to say, instead of printing these out, I'm going to store values in there. Equals, we'll say, x plus 5. All right. Without running this, let's see how well we understand this. Let's see if my little whiteboard thing works here. Ha! All right. So we've got this array. It's got 3 values in it. Right now, I can't remember what the first one was, 23. And then What a hateful bunch. Okay, I've got this, but now I'm saying I'm going to store what? 10. So it's going to replace my 23, it's going to replace my 67, it's going to replace my 100. Then what? See, these numbers out here, these other 7, they're in RAM. 1, 2, 3, 4, 5, 6, 7. These are for really big numbers out here. Okay, so where are these slots? They are. They're not in my array. Here's nums. This is harder than it looks, y'all. My next lifetime I'm going to be a brain surgeon, so I'm just practicing right now. Do what? What's out here? What if this is where I declared nums, and then down here I've got int y, and I stick a 5 in there. If y'all come to my house on Halloween, I'm not giving you candy. I'm telling you that right now. I don't care how you're dressed. Where, y'all, think with me. The 23, the 67, and the 100, how many bytes is each one of those taken up? 4. Where's the next 4-byte thing? Right here in RAM. What comes after my declaration of nums? The declaration of y, which means y is right here. Yeah. Which means by printing out, if we go back to here, by storing x plus 5 into these slots, what did I just do? I trashed out my 5. Any other variables down here, it's just going to march on through and trash them out. What kind of warning did the compiler give me? It's like, okay, you want to drive your truck over the edge of that cliff? I'm right here. I'm right here with you. It's going to be a neat ride all the way down. Let's see what happens in real life here. So we'll do Control F5. Ooh. Here's the little message you get. Runtime check failure. Stack around the variable nums was corrupted. So I just trashed out my whole program. And so I'm going to say abort, which is about all I can do. Notice it didn't print anything out, but we didn't want to print anything out anyway. Okay, so the moral of that story is you are going to have to keep track of where the boundaries are. If you don't, bad things happen. What else have we not talked about? We initialize an array. You can initialize the whole array if you want to, or just part of it. And that pretty much gets what we read, unless somebody has a question. All right, let me stop this recording.